Hello everybody and welcome to whatever this is. Whatever the hell you think this is, I welcome you to it. It's good to see you. I'm glad that you have decided to learn here today. And let's get it. We're going to learn about rational expressions, rational exponents and radicals. But before we begin, I got a quick question for you. What's your bright spot today? My bright spot is nature. I went hiking yesterday, and I just love how beautiful this earth we live in is, especially just after a rain, like it did a couple days ago. So we got all these streams that aren't normally there. Very, very pretty. So, all right, well, let's get to it. Let's get after it. Let's make our bright spot is how much we're going to learn right now. Yeah, it is. You don't believe me, but it is. So here we go. Let's start with a radical. We're going to go with a 3 up there and an 8. So this is a radical sign. So this is a third root of 8. So let's talk about what this symbol means. Okay, let's do that first. What this means is that we are going to multiply to 8, right? That's our goal. We're trying to get to 8, and we're going to do it in that many multiplications. That's what this is all about. So let me draw it. I'm going to go, let's see, 1, break that up here. So we got, starting at 0, we're going to have 1, 2, and 3 multiplications. We're going to get to 8. We're going to start at 1. And this is going to really answer the question of how big is that multiplication? You're saying to yourself, okay, I want to get to 8. I want to get there in 3 multiplying steps. They all have to be the same size, right? Got to multiply by the same value every time. What is that multiplication? As we go to here, we say, well, if I multiply by 2, I'll get to 8 in 3 steps, right? Because 1 times 2 is 2, and 2 times 2 is 4, and 4 times 2 is 8. So the third root of 8 is 2. Beautiful. That wasn't so bad. That was actually kind of fun. I'm kind of glad that we did that. So what the thing you need to learn about the radical sign is that this value up here is always going to be your number of steps or counts, or the number of times you're going to multiply. This value in here is always the number you want to multiply to, right? So this is what we're trying to get to, this number. So trying to get to here. Gorgeous. And then the answer, like what your calculator returns to you or what you figure out, is going to be the size of that multiplication. All right. But I want to go over this direction. There's another way to do these problems. There's another way to do this problem that's the third root of 8. And that's by using rational exponents. Okay, so I'm going to go over here and you rewrite it as 8 to the 1/3. So, oh my gosh, dropping markers like crazy here today. So over here, this is a radical, right? That symbol is a radical. And this is a rational exponent. And they're always kind of connected. They're kind of intimately connected here. So let's look at what 8 to the 1/3 is talking about. So let's draw it first. So first thing to realize with 8 to the 1/3 is that it's written like an exponent. And the base of the exponent is the size of the multiplication. So what we're saying over here is that in 1 multiplication of 8 times, oh, how you gonna do me like that, green marker? Hey, watch this. What the hell is a garbage can? Oh, it's over there. Well, that went in. You're gonna have to believe me. So what we're gonna do is say times 8. We always start at 1 when we're multiplying for reasons we'll get to, okay? So 1 multiplication, we're 8. But this is a fraction. And 1/3 is actually less than 1, so we know we don't want to get all the way to 8. We actually want to break it up into 3 steps. So I'm going to go here and break this into 3 steps. Okay, so there's 1, 2, and 3. Oh, gosh. So then we say to ourselves, oh, how big must these steps be? Well, we got to get to 8 and 3 times the multiplicative steps. So we have to be multiplying by times 2 every time. And the 1/3 says we only want one of these 3. So 1 times 2, of course, is 2. And so 8 to the 1/3 is equal to 2. All right, so then these two are equal to each other. Beautiful, I swear. I really honestly want to start this video over, but I'm not going to do it. I'm not going to do it. I know I've dropped a marker 3 times. I ain't going to do it. All right, so let's look at another one. Okay, let's do over here. We'll go same idea, 3rd root of 8. This time, square it. What's the 3rd root of 8 squared? All right. What do you think it's going to be? Well, let's just do it algebraically first. Like, algebraically, if I'm to look at this, I already know what the 3rd root of 8 is. It's 2. So if this is going to give me 2, that's the size of the multiplication. I want to do 2 multiplications of 2. I'm going to be at 4. There it is. There it is. Okay, let's look over here and do this using a rational exponent. So as a rational exponent, this question is 8 to the 2/3. Which is why, between me and you, I kind of like the rational exponent just a little bit better. But you know, I don't know, it's just faster to me. Like, this is a lot faster to write it this way. So, and what I'm not really showing, but I'll show it here, is that the 3rd root of 8 squared, we know is equal to 8 to the 1/3, right, as we've established earlier. And now using our exponent rules, we multiply when you take a power raised to a higher power, and so that gives you 8 to the 2/3. All right. So now let's look at what this one's saying. This is nice because then I'm just going to use the same picture I did before and say, okay, now I want 2/3. There it is. 8 to the 2/3 is 4. Excellent, excellent. Yes, I know. You're going to be getting it. I feel it. Okay, so here's another one. Ready? Watch this. All right, so then what's 8 to the 3/3? That's going to be 8, right? So what about 8 to the 4/3? What's that going to be? Well, we're going to need more room, and I think I'm going to need more room on the screen. But now we're back. So we're looking at here, right? And we want to go 8 to the 4/3. I want to go 8 to the 4/3. So this is 2/3 is 4, so that's going to be 3/3, gives me 8. So 4/3 just means I need another section, and each one of these sections is going to be a times 2. So then 8 to the 4/3 is going to be 16. Which is nice because it's bigger than 1, right? I know 8 to the first power is 8. That fraction's a little bigger than 8. We get to 16. So we also know, right, that we can rewrite exponent form or rational exponent form in radical form. So I could take that value, I could rewrite it as the 3rd root of 8 raised to the 4th power. Maybe you like that better. So you look at this and you say to yourself, okay, if I got to multiply to 8 in 3 steps, I must be multiplying by 2. And now 4, 2 raised to the 4th, it gives me 16. It's beautiful how it all comes together. All right. So I picked this example because this has some invisible math in it. And the invisible math is I didn't put a number up there. So we know that number is the number of steps or the number of counts. So if you don't see a number, the implication is the number is a 2. That is actually the invisible math of radicals. So it's the square root. We kind of know the square root of 36 is 6, but here's just another reason why. Let's look at another reason why. Well, now we know more about what this symbol says. It says in 2 counts, and they got to be timesy counts. You got to be multiplying each time. You've got to get to 36. It's going to answer the question of what do you multiply by? Well, if you're going to get there in 2 multiplications, those multiplications each have to be of 6. Yes, they do. Yes, they do. So I'm going to write that is equal to 6. Gorgeous. Gorgeous. So now the second problem here, which is the square root of 36 raised to the second power, we now know that that is 6. So let's erase that. And we know that that is going to be 36. Okay? I don't let's make it to the third power. Let's go to the third power. Let's make this a little bit more of a learning opportunity. So let's put it to the third power. Bonus problem, I suppose. So the square root of 36 raised to the third power. So we know square root of 36 is 6. 6 raised to the third power is 6 times 6 is 36 times 6 is 216. 216. And if we continue our drawing, it just means we want 3 counts. And so we're going to multiply by 6 again and get to 216. Now to look at this in rational exponent form, what we would do is this second root of 36, or square root of 36, could be written as 36 to the 1/2, which is such a trip, because a halfway to 36, right? You think students look at a half of 36 and some of them tell me, yo, Mr. Miller, that's got to be 18. Nuh-uh, you adding. That's not, yeah, if I'm adding, I'll get there 18 plus 18. Yeah, I see you. But we're multiplying. That's just what's kind of cool here is to think that if I'm going to go here, right? Just look at this picture. This picture is very, very interesting. Times 36. Okay. That would be 1 multiplication of 36. Boom. But we don't want 1 multiplication. We want a half a multiplication, right? So what we would do is you split this in half, and we only want the first half. Well, if you're going to split it into 2 multiplying steps, those steps have to be times 6 each time. And so you get to 6. So 6 is kind of it's kind of halfway to 36 if you're multiplying. If you're multiplying and you're at 6, you're halfway there. Only 1 more multiplication to go. All right. And so this last problem that I put up there would have been 36 to the 3/2. Which is 36 to the 3/2? Well, we know we would just extend. I know I got maybe just a tiny bit more room to extend this out. There we go. And there's your 1 more for 3, which is going to get you to 216. 216. All right. I like it. I love it. Let's do 1 more. What time am I at? Oh my gosh. Mr. Miller, could you mind hurrying up a little bit? All right. So the question is going to be, I don't know, I think the question is like evaluate, right? Like what is this? Or simplify maybe, however you want to read it. But try to figure out what is 125 raised to the 1/3 power. Hit pause. Unpause. All right. Well, let's get it. First of all, it's kind of cool that you can even figure this out. I mean, it sounds super complicated, right? Oh, what's 125 raised to the 4/3 power? People are like, oh, damn. Raised to a fraction? Are you kidding me? No, I ain't kidding you, but hopefully it's starting to make sense. What we're going to do, and we'll answer both these questions really at the same time. is you've got this line, right? And one count, the base, right, the exponent is 125. So we're going to go times 125. That's if you're going to do a full step. We ain't doing full steps here, right? We only want a third of the steps. Let's break it into threes. There we go. And ask ourselves, like, if you're going to multiply to 125 in 3 steps, what must you be multiplying by? And your calculator will answer that question for you if you type this into your calculator. But what I kind of know, it's 5 times 5 times 5. Okay, so now the first one, we want to take a third of that, so that's going to be equal to 5. This one, 4/3, we want to take 4/3, so I need one more chunk to get to 4/3. So one more times 5 gets me to 625. Oh, all right. And then lastly, whoop, you could write it in radical form. So you could say this. Right, the denominator goes up in the little index. So I'm going to count to 125 in 3 multiplications. That's going to get me 5. And then this one here, it's the same idea. I'm going to get to 125 in 3 multiplications. And whatever that is, I want to do 4 of them. So the number in the numerator is the exponent of radical form. So maybe a conclusion would be this. If we were to say, I don't know, A, B, C, that's going to be equal to A, right? And the B is the denominator, so C over B as like a rule. Well, I don't know. We went somewhere. We get somewhere. I'm happy with it. Hopefully you're happy with it. You're what matters, not me. Yes, I definitely know that's true. Anyways, thank you for being here today. I hope you learned something. Stay hip and be kind to each other. And yeah, enjoy this beautiful earth. Peace out.